Let me go to homework. I didn't post new homework yet. Yeah, I will immediately after class. And it is the homework number 8 from chapter 5, the discrete random variable.
No, this is today's homework. Today's homework.
Yeah, it's 8. Today's homework. What do you want to do? Which one do you want to do? The last one?
The last one.
The last one. Thank you. Okay. Yes. It is number 8, the homework tonight, right? The last problem. There's a range. It's a class limit, right? Yeah. And here is the midpoint. Probably it is the average of the lower limit and upper limit, and lower limit and upper limit, not the average, right? And here is the relative frequencies, the percentages, probability. Now, part A. Use the midpoint. Is it valid or not?
Yes.
It's valid. Yes. Why? Because when I take the sum, did you get 100%? Yeah, why not? It is valid. Good. Right? So I can check. It's X here. Yeah, because the sum is must be 1. And now, yeah, did you make the histogram? Right? Here is the most, and here is the least. Which one? Is the most, least? Just a second. I think that this one is a good one, right? Because here is the most and least. So let me select this one and the first one, and let me check the answers. Yeah, now it is easy, right? And the next one, we need the mean and the standard deviation, right? Yeah. So let me using the Excel. You know, the Excel is a good calculator. So let me copy the table 23, 34, 45, 56, and 67 with the probabilities 0.06, 0.43, 0.21, 0.11, 0.19. And we checked, take the sum, always 100%. Let me take the mean. How? We have to take the multiplication for all parts, then take the sum. 44.34. Let me check. I got the mean 44.34. You got it? It was the mean. What did I do? I take the multiplication with the midpoint. You know, we have class limits from here to here, from here to here, here to here. Midpoint represents this class. Another midpoint for the second class and the third class, right? So 23, 34, 45, they are the represents. It's represent from each class, right? And take the multiplication with the probability and simply take the sum, that will be the mean. Do you have an idea? And how did you get the standard deviation, the sigma? Already we take the mean. Now we take the difference, right? So it's next column. Next column, take the difference. 23 minus the mean. Copy down. Second step. What we did in the third step, take the square. Take it, then take square. And now step 4 was the new one. Multiply the probability. Let's see. And then take the sum. Finally, take the square root of it. So finally, it will be the standard deviation. And the step 4 was a new step. Let me check. So already I got the mean, and now the standard deviation. How many decimals? 2 decimal places. 13.63. You got it? Right? Yeah. So in Excel, I take the multiplication each, take a sum for the mean, and take the difference. 23 minus the mean 44.34 and square, multiply the probability, take the sum, take the square root. That will be standard deviation by 67, right? It's up to you. Yeah, even you can take the differences, square, multiplication with the small calculator. But yeah, it is much faster, easier when you are using Excel. Excel is another calculator. It's the same thing. So it is the quiz number 8 tonight, right? So if you didn't finish the homework, not quiz, the homework number 8, yeah, then please, it's complete. It's by tonight. Okay, today, chapter 5, we are discussing the probability distribution, the random variable, and the random variable was the quantitative, right? With the chance, with the probability. So we had the discrete random variable with the probability, quantitative. So we made the histogram, and we got the mean and the standard deviation. And simply we just reviewed how can we get the mean and the standard deviation by 6 steps, right? Today, I want to introduce you an example. The binomial probability distribution. The binomial probability distribution is one of the discrete random variable. It is the most common discrete random variable in statistics. First of all, we need a fixed number of trials. I want to give you an example. Let me toss a coin 10 times. Number 1, we need a fixed number of trials. How many number of trials? 10. 10, thank you. I tossed one coin 10 times. The number of trials? 10 times, yes. Let me look at number 3 first. I want to look at the number 3 first. We need only 2 outcomes. When I toss a coin, how many outcomes? 2. Head or tail, right? Only 2. Please look at the name of the distribution. Binomial. What does that mean? Bi? 2. Bi, that is a 2. Yeah, it's a bi, that is a 2. two outcomes, right? And now please look at the second part. The n trials independent. See, I got tail. Do I have a more chance to get another tail? No, it's the same, 50-50. If I got tail and tail, now it is head, nobody knows, right? The outcomes are independent. It's every single time. And even we have the same probabilities. Let me say the P is a probability of success. You know, we have only two outcomes. So one is a success and the other one is a failure. Get head, success. What will be the failure? Get tail, right? When I take one of you, female, success, then fail. I'm sorry, yeah, but yeah, one is the success and the other one is the failure, right? Yeah. So probability of success, probability of the head, every single trial, every single course, 50-50, 50-50, 50-50, independent, right? And we have another probability is Q. That is the other one. Tail. The other 50. How? 1 minus 0.5 will be 0.5. So do you remember this equation before? P plus Q must be 1. Q is equal to 1 minus the probability. Have you ever seen? Thank you. In chapter 4, the complement event, brown eyes, blue eyes, male or female, head or tail. When we have only two outcomes, then we can think about the complement probability, the complement event. Yes, that is true. And now, number 5, we can think about a random variable, number of success. Yeah. The random variable now will be number of successes. In this example, I count how many heads. Okay, now I'm tossing a coin 10 times. How many possible smallest number of heads? Possible smallest number of heads? 0. It's very rare, but tail, 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 all tails, no head, right? Then what will be the possible maximum as number of heads? Not 1.
0.
10. I toss 10 times. Can I get 11, 12? No. I just toss only 10 times. It's up to 10, right? So the random variable, the number of successes and number of heads from 0, 1 to 2, up to 10, right? Yeah. I can give you another example. In this example, I have 3 multiple choices. And it has 4 choices. And we have only one answer. 3 questions, 4 multiple choices, and one of them is correct. Let me guess all 3 questions. Yes, I have no idea. Yeah. I didn't prepare. Okay. Guess. What will be the chance I will get correct answer when I guess?
1 out of 4.
1 out of 4. Thank you. When I guess, I have 25% to get the correct answer. What would be the chance I will get incorrect? 75%. 1 minus 0.25 will be the Q. Probability of failure. Incorrect. 0.75. Right? Yeah. So now I can set up how many independent trials? 3. What is the probability of success? 0.25. And what is the probability of failures? 0.75. Can you set up? And my answers, my guess, independent or dependent? If I got correct answer, then do I have a more chance to get correct answer again? No, always 25%, 25%, 25 independent. So exactly it is the binomial probability distribution. And now I can get a random variable. R is the number of successes, number of the correct answers. What is the possible values? How do you think? And we can think about the possible values later. So the random variable is the number of correct answers with the 3 questions with the probability 0.25. Good, right? So now let me make the table. What a lucky day. Success, success, success. Correct, correct, correct. How much will be the probability? Just a second. They are, my answers, my guess, are independent. Where did you get the independent before? What kind of rule? Do you remember the special multiplication rule? For the probability A and B, and when they are independent,
DA times DB.
probability of A times just the probability of B, right? Now, the 3 answers are independent. And I can describe correct and correct and correct. Absolutely. We can apply the special multiplication rule. How? 0.25 times 0.25 times 0.25, right? So the probability, I all correct, that will be 0.25, 0.25, and 0.25. You know, the power is a repeated multiplication. So it's 0.25 with the power 3. I have a 0.0156. Don't even think about that. It's less than 2%. Yeah. What a lucky day, right? Yeah. So now, it's how many number of successes? Or 3. It's almost impossible. Now, let me think about the second case. Success, success, and failure. Correct, correct, incorrect. How much will be the probability? Still, we can apply the special multiplication rule. 0.25 times 0.25 times 0.75. Thank you. Yeah, because the last one will be wrong. So 0.25, 0.25, but 0.75. 0.25 square times 0.75. It will be 0.0469. How many number of successes? 1 and 2. Okay, let me try the next one. Success, failure, success. What did you say? Would be safe. Yeah. Because 0.25, 0.75, another 0.25. You know the multiplication, even I can switch, we are going to have exactly the same answer, right? So it must be 0.25, 75, 25, but it will be same as 0.04 as a 92. Still, only 2 successes, 1 and 2. Please look at the next one. How many successes? 2. How much do you expect the probability? 0.0469 again. Is so far so good, right? How about the next? The next one will be success 0.25, failure, and failure. Oh, it's a new one. So I have to take 0.25 times 0.75 squared. It will be 0.1406. How many successes? Only one. Thank you. And the next two cases, only one again. What do you expect? They will have the same probabilities. 0.1406, 0.1406. So far so good, right? How about the last one? Oh, yeah. 0.75, 0.75, and 0.75. So it must be 0.75 cube power 3. I have a 0.4219. How many successes? No success. You understand what I did? Right? Yeah. I suggested all cases when I guessed 3 questions, 4 multiple choices. How many cases? 1, 2, 3, 4, 5, 6, 7, 8. The 8 combinations, 8 cases, right? But they are saying 2 successes. They are saying only 1 success. Single case, single case. Totally 8. Good? Yes. Any question? Good? Right? Okay, now could you add up the probabilities, please? Now, please take it and 3 times 0.0469. Another 3 times 0.1406. And last one, single, 0.4219. Please add up. Sum up, please. Done? 1. How much did you get? 1. 1. And 1? Thank you. Why not? I told you. Always sum up all possible probabilities must be 100%. 100%. Okay, now let me organize the table again. Yeah, please look at the right-hand side. Here is the random variable, the number of successes. 0, 1, 2, and 3. Yeah, I reorganize again based on the random variable and the number of successes, right? How much was the probability R equals 0? We had a single case which had 0.4219. So let me copy the probability. 0.4219. And the next one is 1 success. 1 success. 1 success. 1 success. How can I do? 3 times 0.1406, right? So let me take all probability. 0.1406 times 3. How much will be? 0.1406 times 3. I have a 0.4218. 0.4218. And the next one will be 0.0469. 6, 9, and another 3 cases. 0.0469 times 3. I have a 0.1407. And the last one is all correct answer. 0.0156. Let me make the table consistently. So it's a times 1 will be 0.4219 and only one case 0.0156. I reorganize the table. You understand what I'm doing? Right? Yeah. We add them up. Oops. These probabilities. How much was it? 100%. Then now, how much do you expect? 1 again. Yes. You can try it. 1 again. Now you understand? Right? So we have 3 independent trials, independent questions, guessing. In each guess, I have a 25% chance to get the correct answer and 75% incorrect. And case by case, I can make the table, I can get the probabilities. Right? You like it?
We use it up a little bit for the
I don't like it. It's too much, I think. I can give you the shortcut, the formula. Okay? I can show you how can we use the formula. It is a formula for the binomial probability distribution. It's basically it has 3 terms, the 3 parts. What is the first one? The first one, the C. The C is a binomial coefficient. I will introduce you what is a C later. But C, the first part, it is the binomial coefficient. The second one, remember what was the P? P was the probability of success. Thank you. And what was the Q? Q was 1 minus the probability of success, and which was the other probability of failure. Was the all was a random variable, which was the number of successes. It can be 0, 1, 2, or 3, because I had 3 questions or yes. And here's the N and N. What was the N? N was the number of independent trials. Right? We can get each probability directly. Let me try. Let me show you. So now I can split again. Okay. I need the space on the right hand side. Good. Right. Okay. Oops. Sorry. Yes. Okay. Now I can say how many N? How many N I had? 3 questions. What was the probability of success? It's not here. Yeah. It's equal to 3, equal to 0.25. And how much was the Q? 0.75. And how many possible number of successes? From 0, 1, 2, or 3. So now in the right hand side, I just copied the formula. The probability R was C and R, P to the R, and the Q n minus R. Let me take the probability when No success. So let me plug how many n? 3. What is the R? Now is equal to 0. What was the probability of success? 0.25. How many R? Now 0. Q, 0.75. N was 3 minus R is equal to 0. It's a plug. It's every single value. And let me take 3 parts separately. C part, 0.25 and 0.75. First of all, the C part. Many of you have a calculator, TI-84. Even I have a TI-84 is here. I can show you later how can you get the C from the TI-30, right? So if you have a TI-30, yeah, please wait for me. If you have a TI-84, then please plug 3 first. Are you ready? And please click the math key. Yeah, here, math. Then you might have 4 or 5 columns. Then please go to the column PRB. PRB stands for the probability. And get down. Number 3, there is a C function. And then plug the 0. How much will be? It will be 1. If you have a TI-30, it's the same thing. Plug 3 first. And now you have a PRB key. Then click it. The second one is the C function. Take it and plug 0, enter, then you will get 1. You have can you see the CRB here? It's the same thing. 3, shift. Yeah, try it, right? Yeah. The shift, take the C function and 0, then that will be 1. You got it? Did you got it? You got it? Yeah. PRB key. You got it? Good. It's a 1. Can I see? Yeah, there's a PRB, right? It's a 3. Go to the PRB key. And second one is a C function. Take it and 0. Enter. Anybody else? Anybody? Any other calculator? You know, most of the calculator. Remember at the beginning of semester, even TI-30, the cheaper calculator, it will be enough, right? It has the C function. So most of the calculator has the C function, right? So please try your calculator to get the C function. Anyway, that will be 1. Can you give me the second part? The 0 power? Always 1. And now, how many powers? 3. So 0.75 power 3. Then I have a 0.4219. When I take the multiplications, it will be 0.4219. Can you see it? X equals 0, 0.4219. Directly, using the formula, we can get the probabilities. One more time. Article 1. Then we need a C3, 1, 0.25 power 1, 0.75, 3 minus 1. Give me the C. Please give me the C. 3. How many? 3. Then how much will be the power 1? Itself, 0.25. And now, how many power? 3 minus 1? Square. 0.75 square it will be 0.5625. Yeah, please take the multiplication. 3 times 0.25 times 0.5625. How much will be? How much will be the multiplication? Did you have a 0.4218 or 19? 9. Okay, thank you. Before I got 4218, but now it is 4219. It's the same. Don't complain to me. Because I had rounding problem. 18, 19. Let me try one more. R equal 2. Probability R equal to C3, 2, 0.25 square and 0.75, 3 minus 2. Give me the C. Give me the C. 3, another 3, thank you. And 0.25 square, 0.0625. Then how many power will be 3 minus 2? 1, then itself, 0.75. Yep, please take the multiplication. When I cheat, it must be 0.107. Did you get 0.1407? Right? Am I right? Am I wrong? Say again?
Yeah, 0.1406 is what I got.
Oh, okay. Oh, come on, it's the same. 0.1406. How much did I got? 0.1407. 06 is the same thing. Why don't you try the last one? The last one by yourself. R equal 3. I guess it must be 0.0156. Am I right? Am I right? Thank you. We don't have to make the tables directly using the formula. We can get the probabilities. You like it? I love it. Yeah, I love formula. Any question? Okay, now then, please look at the C. The C part. It was 1, was 3, was 3. Anybody? How much did you get? The last one? 1 again. Thank you. How do you think? 1, 3, 3, and 1. For the number of cases. No success. F, F, F. Only one case. Y3, one success. S, F, F. F, S, F. F, F, S. How many cases? 3 cases. 2 successes. S, S, F. S, F, S. F, S, S. 3 combinations. All 3 successes, S, 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 only 1 combination. It was a function of C. C stands for the combination. So the C function gave us how many number of combinations, the cases. Good, right? Do you remember how did you get the probability 0.4219? No success, fail, fail, 0.75, 0.75, 0.75. How many 0.75s? 3.75. How many 0.25? No 0.25. You remember how did you get the probability 0.1406? One success, two failures. 1.2, 0.25, 2.75, right? 1.25, 2.7. 0.0469, two successes, 2.2525, one failure, 1.75, two successes, one failure. And the last one, how many successes? 3.25. How many failures? How many 0.75? The power must be 3 minus 3. It's a nothing. The 0. You know, formula is a formula, right? It's exactly within, right? If somebody is made a formula, we will have exactly the same probability, right? Yeah. So it is the formula. It is a shortcut, and plug into the values, then we can get the probabilities, right? And I want to start here because the last class, yeah, I did a little bit more than late. Yeah, finished late. Let me finish chapter 5 on next Monday, and immediately we are going to discuss chapter 6. Okay? Now here's the quiz number 8. I'm sorry, it's a 9. Quiz number 9. Yeah, the example, the last example, it is the quiz. It's a number 9. Yeah, I'm sorry, I didn't finish your grading. It's number 8. So I will give you back on next Monday. It's with this one, right? You know, always for the binomial probability distribution, we need is how many n and what is the probability of success. You know, the n was the number of independent trials. Please read the example number 4 carefully, and please let me know how many n, how many independent trials. How many? 10. We have 10 people. Good, right? Then what will be the probability of success? Say again? 59%, but it must be 0.59. 0.59. Then what is the 6 then? Now we need the probability. R is equal to 6. You understand? Can you set up? Right? And the formula was C n comma R P to the R Q and power n minus R. Now please plug into the numbers into the formula and take the 3 parts separately. The C part, success, failure, and finally, take the all probabilities, and you can get the probability 6 successes. Now here is what is a successes? It's concerning. You know, concerning is not the good one, but anyway. One is the success, and the other one is the failure, right?
So it's Q 0.75.
Q? 0.41. How did you get 41? 1 minus 0.59. It will be the Q. Okay, so thank you. Additionally, the Q will be 0.49. It must be 1 minus the P. So you have to plug the 6 here, 6 here, 6 there. 10, 10. 0.51, 0.49. Right?
41.
Thank you. 41. 59.41. Yes. You got it. But you have to be careful. Let me try to. 10. You got this one. And continuously times 0.59 power 6. So far, we have an 8.8. And continuously, there's 44. How many? You know, when you are doing the homework, you have to be careful the rounding problem. Just continuously like that, then you can use as many as decimals as you can. So that is the better answer. Yes, that is a formula. Yes, the big number. Anybody who got the C? How many? 210 combination. Because we have 10 people, there is a more, it's a huge. 210. But remember, we are going to take all probability. Any probability must be less than 1. So even though the C is 210, but multiply smaller. Multiply small number. It's getting smaller, smaller, smaller. Finally, the probability must be less than 1.
I got everything. I was actually good reviewing.
Yeah, I didn't know the last one. Well, if I remember the first one, I think it's 210. That's what I want to know. That's the function in the calculator with the C. You have to put 10 and then you have to put the C.
Yes, well, yeah, you're right, but I think there is 10.
10. PRV, right?
Then will be
And
10,
then,
right?
where's the
And continuously
So
times
that's the E.
0.59 power 6.
And
So far, it's 8.8, right? Just continuously 0.1 power, how many? That's better.
You celebrate Christmas today?
Have a good weekend. I'm here.